Okay, welcome everyone. This is our scaling lecture. In this lecture, we're going to study EIGRP. So we're basically going to continue with our dynamic routing exploration, and we are currently studying EIGRP protocol. In this lecture, we're going to use a practical configuration to learn EIGRP. I'm going to discuss with you guys about EIGRP, how EIGRP works. If you haven't watched our first theoretical lecture about EIGRP, I strongly suggest you to do so before you actually watch this video. Okay. Now let's go ahead. What we're going to do here is we're going to have three different companies. We're going to have three different networks. All right. So we're going to have three routers. Every single one of these routers will be the edge router that will connect the internal company's network to another company network. So in order to do that, I'm going to grab a few routers. We're just going to grab three 1941s, which are exactly the same ones that we have in our physical lab. So we're going to do that. All right. Now, just like I said, every single one of these routers will be an edge router for a company internal network. So let's do that. So just going to rearrange the routers here on a very easy format in a triangle shape. Okay. Now what we're going to be doing is let's get some circles, some colors to indicate the different company networks that we have here. We're going to have company's A network, which is in yellow. We're going to have a blue, no, not blue, green on the right hand side, which is going to be company's B network. We're also going to have a network for company C. I choose a color here as well. Could be black, doesn't really matter. All right, so this is everything we're going to have. So every single one of these routers is the edge router. That means it's going to be the default gateway for everything inside of the company's network, and it's going to be also a way to reach other networks. So this is exactly what we're going to be doing here. Let's put some names on the diagrams. This is going to be our network C. This is going to be network A. This is going to be network B. All right, cool. Now let's define some IP addresses for every one of these networks. I'm going to grab network A for instance. It's going to be a 192 network /24 using the default subnet mask. We are also going to have network B, which is going to be 192.168.2.0/24 as well. And we're also going to have network C, which is going to be 192.168.3.0/24. So we're going to have these three different networks. And the main purpose of this exercise is we're going to connect all of these edge routers to each other, and we're going to make sure we have full connectivity from one site to another site. Okay, so let's grab a few cables, let's grab a few devices before we do that. So let's put a few switches inside of the company's network, because every company's network will be a local area network. That's exactly what we're going to be doing here. And grab a 2960 and put it on every single one of the internal networks. Cool. After that, we are going to connect these devices. So grab a straight through cable, gigabit 01 of the switch to gigabit 01 of the router. Let's say that. Gigabit 01 of the switch to gigabit 01 of the router here as well. Alright, now this is not that great because black is not that of a good color. I'm just going to change this color here. And use whatever, pink. Few color, shape. Cool. Alright, do the same here. Gigabit 01 of the router to gigabit 01 of the switch. But this is the wrong switch. Grab a 2960. We're going to do the connection as well. 01 to gigabit 01 of the switch. Now we are going to have endpoints inside of the company's network. We're going to simulate that with a computer here, with a laptop here, and we're going to put a server in network C. Right? Doesn't really matter the choice of end devices that you guys make, as long as we configure the appropriate IP addresses. Okay, our next step is connecting the laptop to the switch. Okay, here as well, laptop to switch using the first fast Ethernet port on the switch. Server switch using the first Ethernet port. All right. Now this is everything we need to do for now. Now after that, what we're going to do is we are going to make sure everything within every single one of these LANs is working. So in other words, we need to configure the IP address on the laptop server, the other laptop as well. I'm just going to change this laptop for a computer just to have something different. Yeah. PC, use an Ethernet cable as well. Fast Ethernet 0, 1 to the computer, and that's all we need. Now we're going to configure everything within the company's network. In order to do that, we're going to go to every single one of the machines and set an IP address. For the client machines, the IP address we will assign is the first available address within the network, and for the default gateway is going to be the last IP address in the network. So let's go ahead and do that. PC. This is going to be 192.168.1.1. If I use the tab key, it's going to be the default subnet mask. We are all using default subnet masks everywhere, so we don't need to worry about that. Now the default gateway is going to be the very last available. So in here is going to be 254. Okay. We're going to do the same on the server in network C. Network C is the .3 network. So let's go ahead and do that. IP address. And then we're going to go ahead and type it in the IP address 192.168.3. In this case, the server is going to be 1. Default gateway is going to be 254. So 3254. Cool. Are you guys with me? So far, so good. I'm going to go to the desktop, to the laptop, sorry, and do the same. 192.168.2.1. Default gateway is the 254. Cool. Now come on guys, guide me through the process of configuring the router. I need to configure the router interface connected to the network. How do I do that? I'll go to the router, right? I'm going to change the name of the routers. So it's going to be RTA. This is going to be RTC. This is going to be RTB. And now we need to configure the router interfaces connected to the local area network. In order to do that, we need to go to the router, CLI, and from here we need to do what? We're going to say no to the setup mode. We're going to say enable in the user mode to go to privilege mode. And from here we're going to type in conft to go into global configuration mode. In global configuration mode, we need to activate the interface and assign the interface an IP address. So I'm going to go interface gig 01, IP address 192.168.1.254, 255.255.255.0, no shut. We're going to do the same on the other routers as well. Router B, CLI, no to setup mode, enable in user mode, conft in privilege exec mode. From here, we're going to go to the interface. We're going to assign the interface an IP address. Of course, this router B is for network B, so it's going to be .2.254.255.255.255.0. We're going to do a no shut, bring the interface up, and that's all we need to do. Now let's go back to router C, CLI, do the same, no setup mode, enable in user mode, conft in privilege exec, and let's go ahead to global configuration mode. In here, we're going to go interface gig 01, assign an IP address, 254.255.255.255.0. Here we're going to do a no shutdown, bring the interface up, and now we can get started. Now, all right, so we basically need to make sure all the sites, all the networks, they are connected. Cool. So in order to do that, we have two options. You guys remember we studied these two options. We can do it. Static routing is one option, and the other option is dynamic routing. Now, the focus of this course is dynamic routing. So we are going to implement dynamic routing to make sure all the sites can communicate with themselves. The other option would be static routing, that would be configuring the routes manually, going into the global configuration mode of every single one of these routers and then configuring the route manually. We're not going to do this. This is not the focus of this course. This is the focus of routing and switching. So we're actually going to do this in routing and switching. All right. Now, what we're going to do here, we're going to configure dynamic routing. Specifically, we are going to configure EIGRP to make sure these routers can exchange information which is necessary for them to reach every single one of the networks in all the companies. Okay, this is exactly what we're going to be doing here. Now, in order to accomplish this, we need to make sure we have connectivity from this router to this router, from this router to this router, and this router to this router. That's exactly what we will be doing. Okay. Now, we're going to create some serial connections between the routers. In order to do that, does anyone know what do I need to do? I need to grab a serial cable. Yeah. However, I have no serial port on the routers, so I basically need to install a serial module. Do you guys know how to install a serial module on a router? This is useful. So let's go to the router. So the first step in installing a module. Now, before I install the module, I will have to turn off the device. And because I want to save my config, I'm going to do a do WR. But now that I'm already here, I'm also going to change the host name before I do that. So this is RTA. I'm going to do a do WR. Now I can turn off my router, so I'm going to go physical mode. And here we can actually see the physical layout of the router. We're going to turn it off because otherwise we're not able to install the module. Now the module that will allow us to have a serial connection is the WH-weak2T, and this is exactly what we will install in this router. I'm going to install 2 of these. And that's it. We now have serial capabilities on this router. We can turn it back on. We're going to do the same for both router B and router C. So let's go ahead, router B. Do the same. Let's change the host name. Do WR to save the config. Let's go to physical. Turn it off 2 weeks. Turn it back on. Do the same in router C. Physical. Oops, sorry. Change the host name first. RTC. Do WR to save the config. Go back to physical. Turn the router off. Grab the H-weak. Turn it back on. Okay. Now, if we try to install or uninstall a module while the router is on, it's actually going to give us an error saying that we need to power the device off. Cool. Click OK. And now we're going to wire things here using a serial cable. We're going to connect router A to router C using serial 000 to serial 000. All right. Let's just move things around here a little bit to make sure everything is visible. Cool. Now we're going to do the same for router B. Serial 01 to serial 01. All right. And after that, now this is enough for us to send traffic through all the devices, correct? Because all the devices, they are connected. Now, because we want to study how EIGRP works and how EIGRP deals with the paths, the redundant paths, we are going to grab another serial cable and we are going to build a redundant connection to router B. Okay, so we're going to use serial all ones to serial all ones. Cool. So this is what we have here. Now we need to start configuring the devices to make sure they understand all the sites. Now, before we actually do that, we need to remember that every single one of the router interfaces, they have to be in a different network. So we're basically going to need a network here, a network here, and a network here as well to make sure these two routers can communicate through the serial links. Now, in order to do that, let's go ahead and assign an IP address. It's going to be a point-to-point link. So between router A and router B, it's going to be a 10.1.1.0/30. Remember that a point-to-point link only requires two addresses, and these two addresses are going to be the .1 and .2. All right, so with the subnet mask of /30, we only have two available addresses. After that, we're going to configure this interface to be a .1. This interface will be a .2. Now, from the link between router B and router C, we are also going to have another point-to-point connection, which is going to be 10.2.2.0. It's also going to be a /30 network. Cool. We're going to do the same in here as well. So in here, we're actually going to have 10.3.3.0/30. Cool. Now, in regards to the numbers of the IP addresses, to the specific host addresses on the interfaces, this one will be a .1, this one will be a .2, this one is going to be a .1, oops, and this one is going to be a .2 as well. Now, can anyone guide me through the process of doing this? Anyone? How can I configure the serial ports on the routers? The same way that I did the Ethernet, correct? I'll go to the router, go to the config of the router and set the IP addresses. So let's go ahead and do that. So for router A, enable conft, we're going to do that right now. So interface 0000 is the one that connects to router C, and we're going to assign the following IP address in the 3 network. 255.255. Remember /30? What is /30 in decimal notation, anyone? Anyone? Yeah, cool. You guys are still here? Cool. After that, do we need a no shot? For the serial interfaces, we don't actually need the no shot because the interface is already up. Okay. I'm just going to type it in because I always type it in. Exit. Now we are still here. Let's do the other interface as well. 0, 1, 1. Okay. Let's go. IP address 10.1.1. So this one is a .1. So the same thing here. The decimal notation for the subnet mask is 252. No shut, just because it's my habit. Let's go ahead and go to router B. Before we do that, let's save the config with the do-wy. Now let's go ahead and move to router B. In router B, we're going to follow the same process. CLI, enable conft. Okay, and now we're going to go ahead and type it in the commands. Interface 0010. This is the one in the 10.1.1 network. IP address 10.1.1.2 network. 255.255.255.252. Okay, no shut. After that, we're going to go to the other interface, which is the serial 011. All right, IP address as well. This is the 2 network, so it's going to be a .1. I'm going to do a no shut here as well. Exit, and that's all we need to do for these two. All right. We go to router C, CLI, enable conft. I'm going to do the same. Interface 000 first. IP address 10.3.3.2. 255.255.255.252. No shut to bring the interface up. Cool. Interface 0010. IP address. This is the one in the 10.2.2 network. .2. 255.255.255.252. We're going to do a no shut here as well. That's all we need. Now we're going to do a do-wy here. And in B, because I think I forgot to do that. Yeah, he's done. UWR. We also have a UWR here to save the config. Now I'm going to save these files before we start configuring EIGRP. And that's because when we start studying OSPF, we can use the same topology to study OSPF as well. I'm going to save these topology here. I suggest you do the same. Save it as well because this is going to be useful. I'm going to save in the desktop. That's fine. All right, cool. We're ready now. Let's go ahead and do the config. Does anyone remember what is the command for me to verify that each one of the interfaces on the routers has the correct IP address? What is the command that I need to execute on the router to verify that? So I'll click on the router. What is the command that I need to type it in to verify the interface IP addresses that I just configured? Come on, guys. Come on. Do show run is one. It's going to show me the commands that I have entered. Now, the show IP interface brief is the one that I'm looking for here because it's going to show specific information about the interfaces. If I do a show run, it's going to show me that. But the thing is, if I do a show run, it's also going to show me other stuff. So it might be a little bit hard for me to keep hitting enter until I'm able to see the interface config. So let's do a do show IP interface brief. And we're going to be able to see exactly what we have configured for the interfaces. So interface 000 has this IP address, 0011 has this IP address, and the gigabit has this IP address. Cool. Now, does anyone remember what is the command to verify the routing table in a router? So I can see what are the networks that my router knows about so that I can see what are the networks that are reachable for me from these routers. So does anyone remember the command to verify the routing table? It's a show IP route. So because I'm in the global configuration mode, it's going to be a do show IP route. And this is going to show me all the networks. Now guys, this is important, okay? Because this is the routing table. This is the table that our router is going to make decisions. So it has networks to exit interfaces, all right? Remember that the C, they are the networks themselves. They are the directly connected networks. And L is the local interface. So this is a local interface. If you realize that the subnet mask is a /32, you know that this is just basically the IP address of the interface itself. Okay? Is this clear? Now let's go ahead and configure EIGRP. All right? Now, configuring EIGRP is a straightforward process. All right? In order to configure EIGRP, the first thing we need to do is we need to enable EIGRP router capabilities. And we do that with the command router EIGRP. So I'm going to go to my router A and execute this command, router EIGRP. Now, when I type it in the command router EIGRP, I need the autonomous system number. All right, the autonomous system number. Remember what is an autonomous system number? All devices that are managed by the same administrative entity. So if you have the same administrative entity that will manage all the devices, in this case, this is exactly what we are doing. We are able to manage all the devices in all the networks. So that's why we are using EIGRP. Remember that EIGRP is an interior gateway routing protocol. That means it's used within the same autonomous system. So if I'm going to configure router EIGRP and give an autonomous system number, I need to make sure I give the same autonomous system number everywhere on all the routers that I want to share information. Okay? So is this clear? So that's exactly what we need to do here. We need to put these routers in the same autonomous system number. Now, when we enable EIGRP on a router, we are basically telling these router to accept messages that are multicast messages that are destined to 224.00.10. Now, 224.00.10 is the multicast IP address that EIGRP uses. In other words, it's going to be the destination IP address so that a router can talk to another router. Cool. Now these routers, they're gonna start exchanging messages. These messages are the hello messages. Cool. For more details about all the messages that we have in the EIGRP process, because the hello message is not all that we have. We have hello, request, update, okay? And we have the acknowledgement. So we have all these different message types that EIGRP will use to exchange information. The first message that EIGRP will send between the routers is the hello message. The hello message is crucial when one router wants to establish something called a neighborship with another router. So before they start exchanging routes, before they start talking to themselves, they need to establish something called a neighborship. And this is exactly what we're going to be doing here. In order for a router to form a neighborship, they need to be in the same autonomous system number. Okay? So that's exactly what we need to do. We need to make sure all these routers, they are going to be in the same autonomous system number. So let's give the autonomous system number 1, just because it's the first one we can assign. Now that we have already configured the basic EIGRP, this router is already ready to start talking to the other routers. Okay, it's all ready. So we can start sending messages. Cool. Now, before a router starts sending information about the networks that are directly connected to it, we need to configure the networks that we want this router to tell all the other routers about. And we do that with the command network. So if I type it in network, this is going to be the command that I'm going to type the specific network that I want my router A to share with all the other routers in the EIGRP autonomous system that I configured. Cool. So I'm going to type it in network, and I need to type the networks that I'm connected to. Okay. So in my router A, I have 3 directly connected networks. I want to share information about all of them. Okay, so that all the other routers will receive this information from our router A. All right. Now, what is the network A? So I'm going to type it in 192.168.1.0. That's the address of network A. Now, when I'm dealing with EIGRP, every time I have classless networks, in other words, if they are not classful, if they don't have the default subnet mask, we need to specify the wildcard mask as well. Cool. Now the wildcard mask is the inverse of the subnet mask. So if the subnet mask is 0.0.0.255, the inverse of this would be 255.255.255.0. Okay. So we need to invert the subnet mask to find the wildcard mask. Cool. Having said that, what is the wildcard mask for this network? Anyone? Exactly. Thanks, Don. So if you quite didn't get what Don has posted on the chat, let's do it briefly. So I'm going to bring my notepad in. So how do we calculate the wildcard mask? So just like I said, we're going to invert the subnet mask. And how do we invert the subnet mask? We basically take an all 255 subnet. So we're going to take a /32 subnet, which is all 255s. I'm going to zoom in. So we take the /32, which is all 255's subnet. And from this subnet, we are going to subtract. We're going to subtract the subnet that we want to find the wildcard mask for. So in this case, it's a /24. A /24 is 255.255.255.0. If we subtract these two things, we're going to be able to find the wildcard mask, which is, so we do this in an octet by octet. So the first octet, 255 minus 255 is 0. 255 minus 255, 0 again, 0 again, and 255. Okay, so this is the process to find the wildcard mask. Cool. Having said that, I'm going to give another example. You guys are going to tell me the wildcard mask. What is the wildcard mask for a /30 network? Can anyone give me the answer? What is the wildcard mask for a /30 network? Yep, perfect, Blake. So it's the same process. We're going to do a 255, 255, 255, dot 255, and then we're going to subtract the decimal notation of /30, which is 255, 255, 255, 252. If we do this easy mathematical operation, we're going to get to 0, 0, 0, 3. Cool? Is this clear to everyone? Yes? Is it clear how I found the wildcard mask? Now keep in mind how you find the wildcard mask, because when we're configuring EIGRP, when we're configuring OSPF, and when we're configuring something called an access control list that you guys are going to learn in the future, we actually use a wildcard mask instead of the subnet mask. Okay, clear? Okay, let's keep going. So what are the other two networks that I need to configure in router A that I need to advertise? Anyone? Let's go ahead. So we want to advertise the directly connected networks to router A. That basically means the 10.1.1.0. All right. Now this is not using the default subnet mask, because remember, a default subnet mask for a 10 network is /8. So this is not using the default subnet mask. I'm actually forced to type it in the wildcard mask. If it was a network that was using the default subnet mask, I didn't actually need to type it in the wildcard mask. It would accept the command anyways. Now, because we do have a network with a different subnet mask than the default, we have to type it in. And just as we already saw, this is going to be 003. Cool? Now we're going to do the same on the other as well. The other network connected to router A, which is this one here. All right? Cool? Now this is all the steps that we need to take. These are the compulsory steps in order to form a EIGRP neighborship. Okay? As soon as we define the router EIGRP, we define networks that we want to advertise on both routers, they will establish a neighborship, and then they start communicating with themselves. Now the thing is, there is also one extra command in EIGRP. By default, EIGRP will actually send these EIGRP messages on all the interfaces. So we will send these hello messages to try to find another router everywhere. Okay? But the thing is, we have no routers on the LAN. We have no routers. We just have client machines on the LANs. So there's no need for our router to send out a hello message out of the interface which is connected to the local area network. That would be just a waste of resources, a waste of bandwidth, because messages will be sent here. No one is interested in these type of messages. Cool? So there is a way for us to inhibit the hello messages on a local area network. It's using a special command. It's the command to make the interface a passive interface. Now, if an interface is a passive interface, the network that is connected to the interface is still going to be advertised, but the exception is that no hello messages will be sent out of that specific interface. Now, What is the command to configure an interface as passive? Does anyone know? Has anyone watched the lecture? Come on, guys. Yep. So it's the obvious command, passive interface. Here we're going to specify the interface, gig01. Now, someone asked me during the Cisco Lab session if there was another command that would allow us to enable multiple interfaces as passive at the same time, something like a passive interface range. Unfortunately, there is none. There is one command that helps us enable the interfaces as passive, and this command is the passive interface default. Now, if I type the command passive interface default, this is going to make all the router interfaces as passive. Okay, so we want to make sure if we type it in the passive interface default, we are making all of them passive, and then we have to activate EIGRP on every interface we want to have hello packets. So if we use the default, we're going to have to type it in no passive on the ones that we don't want to be passive. Okay, that's all. So these are the two different passive interface commands. For this one, if we just use the passive interface gig01, we are going to accomplish what we want. Cool? So let's go back, do WR to save the config. All right. Now in this example here, what we do have is we have this connection, and this connection. They are all serial connections. They can operate at a maximum of 1.54 megabits per second. Now, if I leave them all as 1.54, they will all have the same bandwidth. Now, I want to change that bandwidth just because EIGRP will calculate the best paths based on the bandwidth. All right. So what we're going to do is we are going to change the bandwidth on this link. Okay. So this link to router B is going to be a low speed link. So it's going to be a slow link, which is going to be a bandwidth of, let's say, 64 kilobytes per second. Okay. So remember that the bandwidth on this interface is the default for serial, which is 1.54. Here is 1.54, and here we're going to set manually to 64 kilobits per second. Okay. Now, in order for me to change the bandwidth on a router interface, I just need to go to the router interface and type it in the command bandwidth. So let's adjust the bandwidth on this router interface, which is the serial 011, with the command bandwidth, and then we need to type it in kilobits per second. So we're just going to type it in bandwidth 64. Okay. So the artificial bandwidth that we are establishing here is going to be 64 kilobits per second. Okay. All right. So we're going to configure the rest now. I'm going to do exit, do WR to save the config. We're going to finish the config. So we're going to configure EIGRP on this router and on this router, and we're going to see what happens. Now, let's go to router B and do the config. So I'm going to go to router B. We're also going to change the bandwidth on router B interface connecting to router 1, just in case, just to be absolutely sure that's going to be a 64 kilobit per second link. So we're going to go interface 0011, 010. We're going to configure the bandwidth here as well, the artificial bandwidth, to 64 kilobits per second. Save the config. All right. Cool, we're pretty much done. Now let's configure EIGRP on router B. All right, guys, help me out here. Router EIGRP to enable EIGRP on this specific router, and then I need to type it in the autonomous system number. What is the autonomous system number that we configure on router A? They have to be in the same one, so we can actually put it here as well. This is EIGRP, autonomous system number being used is 1. Okay, so we need to be using the same autonomous system number. So what is the command? Router EIGRP1. Cool. Now how about the network commands? I'll give you guys a few seconds to start typing the network commands I need to enter in router B. And if we need to enter a passive interface command, what should be the command that I need to type in router B? Go ahead, guys. I'll give you a few seconds. How about the network commands? So we already have the passive. So the interface that we need to make as passive interface is the interface connected to routers B local area network, which in this case is 01. All right, how about the network commands that I need to type it in? The networks that I want to advertise from router B. Type it in, guys. Few seconds. So I need 3 commands. What are the 3 commands that I need to configure EIGRP on this interface, on the interfaces of router B? Yep. So exactly, I think you guys got it. Yes, perfect. I think you guys got this. So it's going to be network. So the first one, let's advertise the 10.1 first. Wildcard mask is 3. Let's advertise the other network. And let's advertise the local area network connected to router B, which is cool. So we're pretty much done. Now, let's do the same on router C. So on router C, I have to do the exact same thing. Let's go ahead and do it. Cool. So router C is going to be, come on guys, type it in the commands, please. What are the commands that I need to configure EIGRP on router C? Give you guys a few seconds. Yeah. Yes, so passive interface, but we need to do something else first. The networks, there is one more command that we need to type it in to activate EIGRP for IPv4. What's the command? Let's go ahead and do it. So it's going to be router EIGRP1, and then we type it in the networks. So network 192.168.3.0 wildcard mask. We're going to have the same here, 10.2.2.0. Okay, cool. Now I have a message saying that we have a neighbor. We have a neighbor in 331. Cool. So we have formed an adjacency. We have formed a neighborship with router A. Cool. Now let's go ahead and verify the commands that we just typed in again. Now, in order to verify the commands that we typed in, let's do a do show run on all the routers to verify if the commands are correct. I'm going to go to this first router. So this is router EIGRP1. These are the networks. Okay. Now we also need to make this interface a passive interface. So let's go ahead and do it. So router EIGRP1 passive interface dig01. Now let's verify the commands again with the do show run to see the commands that we have just typed in. Okay, so these are the commands that we typed in for our router EIGRP1. Now let's verify if all the other routers they have the correct router configuration for EIGRP. So let's go to router 1, router A, do show run as well. Let's verify the EIGRP config. So this one is configured with router EIGRP1. The passive interface that was configured is passive interface gigabit 01. The network that router A is advertising is 192.168.1.0. It's also advertising the 10.1.10, the 10.3.30. Cool. Now let's go ahead and check router B. Do show run. Verify what's going on here. Passive interface and the networks that are being advertised. Okay, from router B. Cool. Now, there is a very valuable command when we actually want to verify everything that's happening in EIGRP, and this command is the show IP protocols. When we type it in the command show IP protocols, it will actually helps us troubleshoot the dynamic routing protocol that we are using. So if I go to router A and if I type it in do show IP protocols, check it out the information that we have with this command. It actually shows us the EIGRP. Cool. It's EIGRP1. It's going to show us the router ID. Okay. Now we haven't configured the router ID because we all have IPv4 interfaces on all the routers, so we don't actually need to configure it. Now, if we want to configure the router ID in EIGRP, we can do it. We just need to be inside the router EIGRP configuration, and then we type it in EIGRP router ID, and then we can assign a value to the router ID. Please remember that the router ID is in the same format as an IPv4 address, but is not actually an IPv4 address, okay? It's not reachable. It doesn't really matter in the network. It is just a way to identify the routers. Cool? Okay, these are the networks. 192.168.1.0, 10.1.1.30, 10.3.3.30. Okay, let's go ahead and check router B. Do show IP protocols. EIGRP1. This is the metrics. This is the router ID, the active timer, and a few other options as well for advanced EIGRP configuration. We also do have the networks. Cool. Now, please keep in mind one thing here, guys, and that is that the networks that are actually the classful networks, they don't have the class information. They don't actually need the subnet mask, and it's not shown because it's using the default subnet mask. Okay. So whenever we have the default subnet mask, it is not going to show here. Okay. Is this clear? Any questions? Now what we can do is, let's go ahead and check the routing table on all the routers. So I'm going to go to my router A, do show IP route. So my router A has learned about a few networks, including the 10.22 and including the 192.168.3. All right. So how do I know the routes that I have learned through the EIGRP process? We know because they are routes that are shown as D in the routing table. And they show as D in the routing table because they are learned through the dual algorithm. So the dual algorithm is the algorithm used by EIGRP to calculate the best paths to certain networks. All right. So it's basically telling me the best path for me to reach this network, which is the 10.2.2, which is this network here, is actually going through the 10.3.3.2, which is this way. Because after all, this way is slower. All right. So because of the way that EIGRP works, it's telling us that this is the best path. Okay. The same goes for our network C. All right. Now, there is still one thing here in router A which is not complete. Router A still doesn't know about this network connected to router B. All right. So this is exactly what we will fix in the troubleshooting steps. Okay. So we're going to take a few troubleshooting steps and try to see why router A is not able to learn about this network B. Okay. So this is part of the EIGRP troubleshooting process. Okay. So let's do that. Let's investigate why router A doesn't know about network B. The first thing that we need to check is the neighborship. In order for router A to learn about this network, it needs to be a neighbor of router B. Cool? So we need to make sure router B is actually a neighbor of router A. So they need to be friends. Otherwise, they won't be able to exchange information. So we need to make sure that happens as well. All right? Now, we can verify who is neighbor with the command do show IP EIGRP neighbors. This is exactly what we're going to type it in here. So do show IP EIGRP neighbors. We're going to be able to see that we only currently have one neighbor, which is the neighbor connected to serial 00, which is the interface that is connecting to router C. Okay? So this is the neighborship that was formed. This neighborship is not yet formed. Okay? And we need to investigate why. Okay? One of the reasons why a neighborship may not form is because they don't have the same network connecting both of them. So we need to make sure this is working. We need to make sure we can ping router B from router A through this interface. So let's do this test. Router B is supposed to be 2, and we can actually ping router B using this interface. So it's all good here. Let's try to ping the router interface itself. It's also working, so this path is completely fine. Okay, can go from here to here. Now, how about router B? Let's go ahead and check router B. I'm going to go to router B, and let's verify what's going on in the EIGRP protocols, because after all, they can ping why they're not forming the adjacency. So let's check it out. So this is EIGRP1. Automatic summarization has been disabled. We have the routing for networks. Let's check the subnet mask on all the interfaces with the do show IP interface brief. They need to be all correct. So this IP address is correct. This IP address is correct. Do show run to verify the commands that we typed in. So on 010, we have the IP address configured to 10.1.1.2, which is the correct one. This subnet mask needs to match with the other subnet mask, so we need to confirm that as well. This is all good, this connection. How about the local area network? Gigabit 01, it's all fine. Okay. Now the command that we typed in, EIGRP space 1, and then we activated for the interfaces, the 10.1.1, the 003, and the 192.168.0.2.0. Okay. All right. So let's investigate these route as well. Do show run to verify the interfaces that we configured. This one is the 10.3.3.2. Yeah. Subnet mask is fine. 10.2.2. Subnet mask is also fine. We have a passive interface on router C, which has the correct commands. Okay, let's go to router B because the problem is with router B. Now, just to be sure, what I'm going to do, I'm going to erase the EIGRP config that I did. So I'm going to type it in no router EIGRP just to start over again. Maybe we mistyped something. Let's verify the do show run again. We have no more EIGRP, so let's go ahead and start configuring it again. Let's go ahead, router EIGRP1. We need to type it in the networks, 10.1.1.0, 0.0.0.3, 10.2.2.0, 0.0.0.3. After that, we need to type it in the local area network. Cool. After that, we need to type it in the passive interface, which is gigabit 01. All right, cool. Now let's move on to simulation mode and see what's going to happen. So in simulation mode, we are able to see the messages that are exchanged between the routers. I'm just going to move on a little bit more. To be able to see the entire process. This is EIGRP, so router B is sending a message to router C, which is EIGRP. However, this message is being dropped. And why is it? It might be an issue with the config. You'll see. So as we can clearly see here, EIGRP is actually using the multicast address to contact the neighbor. So the device looks up, yeah, decapsulates, does not come from the same subnet. So there is a subnet issue with one of these connections. So there is a subnet issue with this link. So we need to make sure we fix that issue in order to make sure the neighborship can be established. All right. So if I keep moving on to see the other issues that we may have with EIGRP, there's going to be a point where router B will try to send a hello message to router A, and router A is going to try to send a hello message to router B. The hello message that is being sent by router A to router C is working, as we can clearly see here. Okay, it's an EIGRP message. Okay, they become friends, so they are neighbors. The device resets the timers for the neighbors. They are clearly working fine. Now, the thing that is not working fine here is the relationship between router B and everybody else. Okay, so we need to try to fix that. So let's move on, check what else is there. So router A sends a hello message to router B. Router B is not accepting it. Okay, and why is it not accepting it? It decapsulates it, and then EIGRP does not come from the same subnet as serial 011. So basically what I've done here, I think I swapped these two interfaces. So these two interfaces in router B, they're just basically weird. Okay. So if I move, let's move. Yep. So you guys see what happens here? So because of the way that my router was positioned, I thought that this was supposed to be serial 011, but it's not. It's the opposite. Okay. If I move it, check it out. This is actually my 011 and this is my 010. If I move it, it swapped it. It's just a bit weird. Okay, so we're gonna fix that. So in order to fix that, we just need to go to router B and make sure we change the IP address on the interfaces. Okay, so let's go back to real time. I want to make sure this is fine. So I'm just gonna make sure. So this one is actually the one that is going to be in serial 011. So it's actually, this is not helping it at all. So it's basically on top of this link, but it's not actually this link. Gonna move this. Yeah. So we just basically need to change the IP address on these two. Okay. I'm gonna go to router B, and we're going to do that. So if I do show IP interface brief, what we basically need to do to fix this is invert this address with this address on the interfaces, and everything is gonna work fine. Now what I'm going to do is I'm gonna shut down both interfaces before I start doing that. So interface 0010, shut down before I start making the changes. I'm gonna remove the IP address configuration, no IP address. Okay, I'm gonna do the same on the other serial. Okay. Now, if we're gonna type it in, do show IP interface brief. That's all good. Now, what we're going to do is we are going to make the necessary changes. So we're gonna go router B, interface, interface serial 011 is the one that is supposed to be in the 10.1 network. So set the IP address to no shut. And now we are friends with the first router. Okay. Now we need to fix the second one to form a neighborship with the other router as well. Interface 010. This is going to be IP address 10.2.2.1. and then we're going to do a no shut. That's going to bring the interface up. Okay. Now we're going to do a do show IP interface brief to verify what we have just done. And now we are also friends with the other router as well. Okay. Cool. So these are the steps that we need to take, guys, in order to troubleshoot EIGRP. If the routers, they are not in the same network, they are not using the same subnet to reach themselves, they are not going to form a neighborship. If they don't form a neighborship, they cannot exchange routes. Now that we just troubleshoot what the problem was, which was basically the interface IP address, this one is a little bit messed up because it confuses us. So what we basically do is to troubleshoot EIGRP, we want to make sure every single router can send messages to the other routers and that they can communicate. If we move back to simulation mode just like we did to troubleshoot, we're going to be able to see that when they start sending EIGRP messages, router A sends one to router C receives it, and then they become friends, they form a neighborship. If we continue, when router A sends a hello message to router B, which is a message saying that they want to become friends, router B will now accept because these messages coming from the same subnet. Okay. So in order for a neighborship to form, they need to be coming from the same subnet. They need to be connected through the same network. These networks need to be advertised in EIGRP, and they also need to be in the same autonomous system number. If they're in the same autonomous system number, they are in the same subnet, they can talk to themselves, they have the appropriate network commands, they will become EIGRP neighbors and they will start exchanging the routes. Okay. If we move back to real time and we speed things up, okay, after everything converges, so you remember last class we discussed about this term convergency. Now when everything converges, all the information, all the necessary information is exchanged, and there is a way that every single one of the routers can reach the other router, the other networks. So if we go to router A and we actually verify the routing table once again with the command show IP route, we're going to be able to see that router A has now learned about all the networks connected to it. Okay. Now router A has learned, using EIGRP, it has learned about the two network, which is just basically network B. It has also learned about the three network, which is network C. Okay. It has also learned about these as well. Okay. And what is this? This is the point-to-point connection between router C and router B. Because remember, router A only knows about these two point-to-point connections that are directly connected to it. It doesn't know about this one because this one is remote for router A. It's not directly connected to it. Okay. Cool, is this clear? So these are all the networks that router A knows about. Now, my question to you guys is, if I want to ping from PC0 to laptop 1, which way do you guys think my packet will be forwarded? So I'm going to send the packet from PC0 all the way to laptop 1. Which way will my packet go? Will it go up to router C or will it go directly to router B? Based on the scenario here, guys, what do you reckon? It's good. So don't think it's gonna go up. Does anyone thinks the best way is going this way? Now, do you guys remember our dynamic routing class that we discussed about RIP? So RIP makes decisions based on what? Based on the lowest amount of hops. So if we were using RIP here instead of EIGRP, my packet would go straight away to the laptop. It will go router B and then straight away to the laptop. Now, because we are not using RIP, the hop count is not that important. Okay, the bandwidth is actually more important than the hop count. Okay, so because EIGRP uses bandwidth and delay by default, the high-speed link should be the one chosen. So let's do a simulation and see if that's going to happen. So I'm going to go PC0, and I'm going to type it in the command ping. But before we execute these tests, let's go to simulation mode. So we're going to type it in ping 192.168.2.1. Cool. So let's go ahead and see what is going to happen. Of course, the first few packets there are ARP because it needs to find out the IP to MAC address translation of the default gateway. So this is exactly what's going to happen first. So ARP, router A will reply back because that's the gateway. So router A will reply back with an entry for ARP for PC0. Cool. So now PC0 knows what's the IP to MAC address of router A. Now it's able to build the packet to the destination. And that's exactly what it does. Okay. And oops. And check it out what happens when the packet is leaving router A. It's actually going up. Okay. So this packet goes up and then it comes down to router B, and then router B will finally send it to the destination. If I go to my PC0, check it out, mates. What's going to happen? I'm going to speed up things here for the reply to come back. Oops. Let me just remove this. Go back to real time. Speed things up. Go to PC0, command prompt. All right. So we basically have a reply from the laptop in network B directly to PC0. Okay. Remember that the first one usually fails because of ARP. Now that we already have an entry in the ARP table, and we can check that with the ARP-A. Now we have an entry for the default gateway. This is most likely not going to happen again. So if I execute the test again, it's going to go straight away. Okay. Is this clear, guys? Clear to you? Now you know why these fails. This usually fails for the first time because of ARP. Okay. Once we find out what the default gateway IP to MAC address mapping is, we have an entry in the ARP table. We can then build the packet which is directly to the destination. Okay. Now that we know the MAC address of the gateway. Cool. Now there are just a few things more I'd like to show you guys. So the path that PC0 actually sent the packet was this way. Okay, the longest way. It's the longest way because it has to go up to another router and then down to router B. It's not going directly to router B. Okay. Now, this choice only happened because we changed the bandwidth in this link. Okay. If we change the bandwidth here again, maybe change it back to 1.5, it's going to go straight away if it needs to go to network B. Okay. Now, one more question to you guys is, if I send a packet now, instead of sending to network A's laptop, if I send it to the server, which way will my packet choose? Which way will my packet be forwarded? Will it go straight away to router C, or will it go this way and then back to router C? Which way should the packet go? Anyone? Which way will my packet go if I ping the server? Will it go up straight away, or will it go router B and then back? Come on, guys. It will go up. Now, think about this. EIGRP will calculate the bandwidth. Now, EIGRP, when it chooses the best path, EIGRP will choose the best path based on the slowest link, okay? Based on the slowest bandwidth along the way. Even though we have 64 kilobits per second here, and then here we have 1.5, still the lowest link would be this way, okay? I have multiple paths, but still the slowest is the 64. So it's still not the best decision. So let's go ahead and do that. Ping 192.168.3.1. and see what happens. So I'm going to move back to simulation mode. Oops. Nope, it's already done. Okay, so that's our packet. So it's leaving router A and then directly to router C. Okay. So congratulations for those of you guys that got this correctly. Okay, so it goes straight away. Cool. Now pay attention to these guys. Just one more thing here that we need to study. Mate, I actually have multiple paths. Okay, even though one is not that great, it's still one path that I could potentially take. So let's say if this link fails, okay, if for some reason this link goes down, I have an alternative way to reach the destination. This alternative way is the backup. Okay, this is a backup route. Cool. Now, if this was the same bandwidth, this would be something called the equal cost. So if the way that I can reach a destination is the same, okay, they are both equal cost, the same metric, we have something called equal cost load balancing. Now let's go back to router A because I need to show you guys something interesting. If I show the routing table, let's go ahead and show IP route. These are the entries for the dual algorithm. These are the entries for the networks that I have just learned. For example, this one, 192.2.0, it's telling me that it will choose to take the 3. So it will choose to take this way. Based on what? Based on the calculations. And the calculations, remember, for EIGRP, they consider the bandwidth and the delay by default. Okay? You can include other stuff in EIGRP if you want, such as load and reliability, but by default, it will just do the calculations based on the bandwidth and the delay. Now, there is one nice command, show IP EIGRP topology. This command will actually shows us everything, okay? Including the one which is not the best choice. Pay attention to this entry here, okay? And remember from the lecture that whenever we have P in the EIGRP topology table, that means a good thing. P means it's passive, P means it has converged, P means it's all good, okay? Now, if there was an A instead of a P, that would mean it's active. That means something failed and now it's recalculating everything again. Okay? Now, because there is a P there, it's good. Now, check this, which is just basically the paths that we can take to reach network B. Check it out. It actually says that there are 2 ways to do that. Okay? EIGRP understands that there are 2 ways to get there. Okay? EIGRP knows about it. It's pretty cool. It knows about the perfect, which is the successor route, the good route, which is the one on top. Okay, and because this is the perfect route, the best route, and it's the best route because it has the lowest metric. So check it out. The metric here is this, and the metric here is this. So the lowest metric is the best one, and that's why this is the one that is actually in the routing table. Okay. Now, this one is a backup route. And this is the cool thing about EIGRP. If this link fails, the good link fails, the backup link can still be used. So we can still forward traffic. And what happens with EIGRP is if the good one fails, okay, if the active one fails, the one with the lowest metric fails, EIGRP will immediately install the second one in the routing table. For some reason this fails, for some reason this interface goes down, this one will be the alternative path. This one will be immediately installed in the routing table. So it also works as a backup path, a backup route. So it's also known as a backup route. Is this clear, guys? This is everything you need to know for EIGRP pretty much. Okay. Now, if you take everything that we explained in this lecture and you apply for EIGRP for IPv6, including the way that the networks work, including hello messages, the multicast traffic for the hello messages, the autonomous system number, everything applies to EIGRP for IPv6 as well. Pretty much all the concepts, they are exactly the same. Cool. Now, I have recorded the Cisco Lab session where I configure EIGRP for IPv6. Please make sure you watch that. All right.